Alright, we have a blonde Bandmaster in the shop today. Customer saying it had a weak vibrato, but we'll give it a total thorough going through, make sure it's up and running to spec and sounding good. Gonna review the cord out here. Put 3-prong on there. A little more room to get back there in these heads. When he told me he was bringing me a blonde Bandmaster, I was hoping it'd be another year or two earlier where it would have harmonic vibrato, but no such luck. This is still a cool amp though. And it looks pretty much untouched. Well, maybe. One of the first things I'm going to do is pop the cap pan and see if it's been recapped. Because if it hasn't, it will surely need it. And it hasn't. Alright, with the cap pan off, let's take a little bit closer look here. Now, I don't know if you can quite see it. There we go. But they're starting to bubble on the end, so definitely need to replace them. Alright, let's take a look at the inside of this thing. For the most part, it looks pretty clean and original. Except I'm not exactly sure what's going on here with this grounding scheme they got going on. It doesn't look factory. Otherwise, all in all, a pretty clean looking Bandmaster. And again, we'll probably end up replacing filter caps there. And definitely the bias cap. Don't forget the bias cap. That also needs to be replaced. Alright, we got it on the other side. We'll be replacing all the filter caps here, the high voltage filter caps. I'll also be checking all the resistors and stuff in the power supply section, make sure they're within tolerance. And get it up and going, and then if we have any more issues, we can tackle them then. So before I get started, I always like to check and make sure I have no voltage across the filter caps. Definitely don't want to get zapped by these. That is not a good thing and very dangerous. If they weren't drained, I would just hook up my bleeder resistor, which I have sitting here somewhere, I think. Anyway, yeah, there we go. So I just have a, you know, a low ohm, I think it's a 560 ohm 10 watt resistor with some leads on it. I'll just put one end on ground, one end on the positive of the filter caps, and kind of let them slowly drain. And then go ahead and start taking them out. Oops. And to do the job, a long time ago, I invested in one of these, which is it just makes the job so much quicker and easier. The vacuum powered desoldering gun. It's actually part of my whole soldering station. Let it get good and hot and suck the solder right out of there. It does a good job and gets most of it out of there. You might have to go back with some solder wick if you need to and clean them a little better, but for the most part it makes a quick work of it. That is quite the glob of solder on these. These look original, but the solder on them is kind of a little globby, let's put it that way. Because there's so much solder, I gotta let it sit on there a while in order for it to kind of melt all the way through. All right, we are back. I'm gonna pull the caps out. I always, I've taken pictures of it to make sure I get stuff back in the right way. I've worked on the Fenders, it's pretty easy for me to do. But another thing that's kind of handy, sometimes I'll just put a piece of tape down and mark the polarity of all the caps. Make sure they go back in the right way. With these, there's always these right here that are in series. So you gotta be careful to make sure they're right when you put them back in. Like I said, I get pretty much most of the solder off, but still a little bit left. I could use a little bit of solder on my gun. To give me a little helping hand there. Of course, being as I'm doing this on camera, it's not going to be very cooperating. It's very possible they got these tied together underneath too. There we go. Now we're making progress. think that one is tied in over here. As is that one probably. There we go. For these, I'm just actually going to snip them right here. I'm pretty sure they have these negative ends just jumping across under there. Now, for these ones in series, and the reason they put them in a series, these are on the plate, and they're really high voltage, the highest voltage in the amp, and if you put caps in series, you'll actually combine the voltage. So these are 350 volt caps in series, and effectively turns them into one 700 volt cap, but it does lower the microfarad. The microfarads will be half of this, so 70 on each one of these. Oh wait, it doesn't do anything. I think we're just going to snip those. Use some solder. We have to go back here and clean up the holes a bit. All right, we have the power supply board all cleaned up and ready for new caps. I'm gonna go ahead and check the resistors, make sure they're within tolerance. There's something I noticed on this one. This is when they're transitioning in the black face from the blonde amps. The AA763 schematic does not have bleeder resistors between the first two caps. The AB763, which is your standard blackface schematic, does. So if you look at the tube chart, this does say AA763, and it's a blonde, but it actually has some of the blackface modifications that were done. So, very interesting. So right here we should have a 4.7K, 4.5, which is close enough, 1K, about right on the money, and two 220K bleeders. And there we go. And none of them look really like they've really gotten hot or burnt, so I'm just going to leave those. And get ready to install the new caps. Okay. So what I use for filter caps in pretty much every amp I have or redo or work on are, see if I can get that to show up. Maybe. Anyway, they're F&T filter caps, really good high quality filter caps, and I've really never had an issue with them. So I have a couple 80s and a bunch of 22s for over here. These were originally 70s, and those were originally 20, so 2022 is close enough, and 70 and 80 will work close enough too. So now I'll get these all situated and put in. As usual, make sure and orientate the caps right. That's one reason I like cleaning all the solder out of the holes. It just makes it so much easier to sit them in place and resolder them. And to make it look really nice and neat. A little trick I picked up a long time ago, most people working in electronics will use 60-40 rosin core solder. And I learned that if you use 63-37, which is different, just a difference in amount of tin to lead ratio, this stuff will melt and set at about the same temperature, whereas 60-40 will melt at a fairly high temperature and it won't set to a lower temperature. So it means you gotta sit there and really wait for it to cool down until it will set. This stuff's pretty much almost instant, which is really nice. Keep it from burning your hands. If anybody has any questions or comments on tube amps and repair anything like that, feel free to put something in the comment section. And as also the obligatory, like, subscribe, all that fun stuff. I'm very terrible at self-promotion. Probably being a little too fussy, but I like stuff to fit really well, and I have too much of an issue with it, so. I like to make it look nice and neat. There we go. I always like to put a little bit of solder on the tip of my iron so it makes better contact to heat everything up. I'll make sure everything's heated up so we don't get any cold solder joints. And just let the solder flow right in there. If you kind of notice, these new caps are quite a bit smaller. That's just technology making things more compact and a little higher quality. So a little smaller, but still pack the same punch. Fact is, I have seen a couple instances where people have taken in X-rayed or taken apart newer Sprague caps, which are larger, and actually everything inside them is about that big. They just make them larger to fit more like the older ones, I guess, would be probably why. Oops. Guess I could have let that sit a little bit longer. There we go. Trim them off a little more to get them sit flatter on the board. Whoops. Always check your parts. Somehow I must have got a 16 in with my 20s in my parts bin. Not that it would have hurt anything, but make sure you do the job right. This one will be a little tricky. It's got a lot of wires in there. So there's not a lot of real estate to try and poke that down in there. Make sure it gets down in there. There we go. I'm going to run and grab another 22. This one I'm going to heat up and just push in there. This one I didn't quite clean everything out because again there's a bunch of wires coming in. It makes it a little hard to work around. There we go. Make sure the wire gets warm on the capacitor too, so we don't end up with a cold solder joint. And then one last connection here. just like that, we have the power supply recapped. Alright, we'll take a look at it here and show you what it looks like. Everything's oriented the right way. You got good solder joints, all the resistors are good. And that should do it for this side of the amp. Alright, we're going to get started on this side of the amp. Going to replace all the electrolytics in here. Get rid of that pesky death cap and put a proper 3-prong grounded cord in there. And this is driving me nuts, so I'll probably do something with this also. It's definitely not a factory. We got some weird grounding going on there. It'll probably work fine, but I'm just worried about noise and interference. So, a couple places I also like to pay particular attention to: screen grid resistors. They can get really hot and change value or open up. I've seen them crack and break, so we'll make sure we check those. Once we get all the caps changed and 3-prong cord in, we'll fire everything up, check bias, and then I check voltages, make sure everything's in spec, and go from there. Oh, and also clean all these pots. Alright, before I start doing any soldering or work on the caps, I want to go through and clean all the pots. I'll end up cleaning the jacks too. I usually just run a little piece of sandpaper, I don't know if you can see it, in between the switching contacts there, just to kind of get any corrosion out of there on these and this one back here. But these pots are really nice, easy to clean. I'll just throw some good old deoxit in there, and then run it back and forth. Just like that. And also I should put a little bit in the bright switch and clean that up too. Then go on to the second channel. There we go with that. Yes, I just like to take a little bit of sandpaper, fine stuff, in between the contacts. Just rub it back and forth a little bit. Doesn't take much. These old Switchcraft jacks are virtually indestructible. They're awesome switching jacks. The new production ones, not so much. When I first started building amps, I was like, Switchcraft's a good brand, so I went and bought a bunch of them, built some amps, and ended up replacing every single one. Now I use Cliff jacks, because I haven't had problems with those, but every single new production Switchcraft switching jack I put in an amp, I ended up replacing them all. So I think what we'll do is pull them out, clean up the holes with manual solder sucker or a little bit of solder wick. And that one, back, I wonder if most of them are going to be like that. The ground on this actually goes all the way up to here, it looks like. So we'll just snip it. Let's see how this one shakes out. Looks like somebody has probably factory spliced that one there. Yep, that is too. Oh, okay. Looks like they're all going to be grounded like that. So we're just going to do that. And we're going to pull them out here. And these two over here are actually doubles. There's two 25 microfarad caps in one. There we go. Alright, being as I got the capacitors out of the way, I want to check the resistors in here to make sure they're good, because the capacitors kind of cover them up. So we should have 1.6, which is good. Okay, 1.4, 820, this one's 9, so a little bit high. I'm not going to worry about that. And this one is showing 3.8, and I think it should be 2.7, so that's fairly close to. The tolerances in these old amps are quite wide, so as long as it's not extremely far out, I'm just going to leave them. Oh, and we got one over here, which is 98K it's showing. I'm going to look at the schematic and make sure that is right. I think it's probably supposed to be 100K, so, which is fine. Yep, 100K, and we're good there. So those resistors are good. Being as I got my meter out, I want to check my, see if I can scoot this over a little bit. I'm going to check the screen grids. And this should be 470. $490. Oh, that one is showing me 600. That one actually has gone high. Oh, let's check this again. Yeah, so I might should replace both of them. This one's gone high, this one's a little bit out, so I think I might replace both of those with some. Alright, time to start replacing the caps. I didn't film it, but I did get the bias cap replaced over here. So now, start working on the cathode bypass caps. And sometimes I'll actually float these off the board a little bit. Keep them away from the heat of the resistors. a little longer lifespan. I'm using a Mojotone Mod electrolytics. That's what I had in stock, and they're a pretty good capacitor. Haven't had any problems with them, so. And as usual, watch your polarity with the electrolytic caps. Like I said, I try to keep them away from the resistors a bit. Not that these get that hot, the cathode ones, but there we go. And where these had a double cap can, I'm just gonna use singles. Oops. There we go. I find one more cap. There we go. Probably a little bit long. Welcome back. I apologize, my batteries went dead, so we didn't catch some of the stuff I did here. We went ahead and put the 3-prong power cord in. We have it grounded here to this transformer bolt and soldered in. Got rid of the little death cap that was down here. If those things short to ground, you can actually put voltage on the chassis, which is really dangerous. So this switch actually does nothing. It's just acting as a terminal block for wires right now. Came in, it's got polarized plugs, we left that in. The narrow is hot, the wide is neutral, so hot's over here. The original amps went from the hot to the switch to the fuse. So when we redo it, we go from the hot to the fuse to the switch, so the fuse is first in line. And then of course the neutral just comes to the transformer right here and makes it much safer. I also went ahead, and I don't know if you remember that weird grounding thing they had going in here. That was driving me nuts. It was just, to me, it looked like a spot for ground loop problems. So what we did is we got rid of that big bundle of wires. The cathodes were still grounded right here with their little braided wire, so that was fine. We took the DC, high voltage DC ground, put it right here, and we took the AC grounds right, trying to do this with my camera, right here, and grounded them down to this bolt. So that should be fine. We shouldn't have any issues. Otherwise, we left the other preamp grounds just as they were. So we're actually about ready to fire it up and bias it up and see what happens. We'll adjust the bias with this. I got a little Weber bias tester here. I can go between plate voltage and current. So I'm gonna look up the specs and get it biased up and go from there, see how it sounds. Alright, we got it fired up and got the bias meter in. If I flip my switch, we're running about 450 plate volts, which translates into about, I think it's like 45 milliamps. I got it biased in at about 42, a little shy, which we'll leave it at that. Everything seems to be going good. The schematic calls out for, I think, around 440, a little less plate volts, but that was back in the day when your wall voltage was only 110, so everything's going to run a little bit higher. So that's to be expected. All right. So we've gotten everything replaced that we wanted to replace. Got the amp up, got the amp biased. We're going to fire it up, and I'd like to do kind of just a quick test. I'll run a signal through it and make sure everything works. So we'll fire it up and let it warm up here. Let's do this real quick. So over here, just to give you a little tour of what I got going on. I have my signal generator, just for testing stuff, running signals, and I can scope stuff out. And a couple of bench meters that I use once in a while. A lot of times I use my iPad for schematics and stuff. It's just easier than printing stuff out. Over here, my soldering station with the desoldering. I'm gonna turn that on in case I need a solder over here. Hot air solder. Just kind of your standard workbench. And actually have the amp plugged into my Weber attenuator, which just kind of my generic benchtop attenuator. Works pretty well for what I do. So let's get set up here. I'll turn on I don't know if you can hear that. Right switch works, volume works, treble works, bass works. If I turn so we know that works. Everything's pretty smooth too, no crackling. So let's go over to this side. Bass works, treble works. Try to see if the bright works here. Sounds like it. I'll plug your guitar in later and check it. So let's check out the trim. They said this was the problem when it came in, that it was kind of weak. So hopefully you can hear that. It's pretty strong. I'm kind of losing in there, and it. I don't know if it's a little fast maybe, but it definitely isn't acting right. So a lot of times, well, I'll do this on most amps. I'll go through and start checking the voltage. I'm gonna pull the plug out here so the vibrato shuts off. Got my meter over here so you can kind of watch as I go along. And maybe I don't know if you'll be able to see it, but I'll put my iPad down here. I actually pulled up the AB763 schematic because the other one was just really hard to read, and they're virtually the same amp with just a couple differences. So the A73 and the AB763. So we're gonna just kind of go across and start checking voltages. So plate voltage 272, should be 260. It's actually everything's gonna read a little high because the wall voltage is higher. Grid 2.1, 2.2, 1.9. We're good there. Come over to this plate, 307, and it should be 275. That's a little high. I would bet this resistor's probably drifted a bit. And if we go to the cathode, 2.3, and it should be 2, so that's about right. I think I'll be checking that resistor out. Let's go to the next stage here, and we should have 280 and, oh, that's vibrato. Let's go down to the normal first here. Should have same thing, 260, 265. Let's get the plate over here. 265, probably around 260. Yeah, 265, that's good. Cathode back here should be 2. Since we're having some weird issues with the speed, the intensity seems right. It seems the speed's a little goofy. In the way the circuit works, it's kind of propagation of delay across the capacitors they charge and discharge. If these vary quite a bit, or change value, it'll change the speed. I would bet that's probably what's happening. One of these is probably shorted or drifted. So let's see if we can figure that out. Actually, let's double check our voltage again, because like I said, don't like to get zapped. Fact is, it's a good time to show you how I do this. Ground one side of the bleeder resistor, then I usually find the blue or brown transformer wire, high voltage wire, and there we go. And now we are no voltage. Just remember to take that off when you fire it up. Not that I haven't done that 10 or 20 times before in the past. Okay, let's see if we can get a reading across these. Right around 100 nanofarads, which is 0.1. That 0.1, or gotta do my conversion right here. 100 nanofarads is 0.1 microfarads, yes. That shows 0.01. Checking stuff in the circuit sometimes is not very good. 25, that's actually, let's look at our caps real quick. 01, 01, and 02 microfarads. So, tell you what I'm probably going to do. See, this is my 02, so that should be 20 or 20 nanofarads, right? 20 nanofarads, and this should be 10. That's showing 20. This one's showing a lot. Usually what I'll do with this, I'll actually start pulling legs out and then checking them in the circuit to see what I can see. Alright, I'm going to try and slow this trim down a bit. I'm going to take the two 0.01 microfarads and replace them with 0.02s. This could take longer for those caps to charge and discharge. Which hopefully slows it down a bit so it's more usable. So we shall try that and see what happens. a little bit. There we go. There, so now we have all 22s instead of 01s up here. Let's see how that shakes out. Oh, there we go. Much more usable range. Alright, that's enough of that annoying test tone. Let's plug in a guitar and see how it sounds. Alright. Really good for the vibrato channel. Don't have the greatest speaker in there. It's kind of a crappy import vintage 30, so but everything